This is for in class 11. It is the technology standard. To start, we're going to talk about correlations of data points. In class, I was a little bit more careful about how I did this, as in thickness of my dots. The biggest thing is just seeing the relationship. So a no correlation is just a bunch of points all over the place. Looks like snow. Negative correlation is your data points follow a negative trend, and a positive correlation follow a positive trend. So if you were to take a line of fit, you would draw a line in that would fit your data. And if you look at these two lines I drew, this one has a negative slope, this one has a positive slope, and there's no line that I could draw that would fit the data. Prediction equation is a regression line. It's an equation of this line, sometimes referred to as the line of best fit. So predictions of one variable can be made for another variable, meaning you get a creative equation, linear equation, and we can use the x value as our predictor to find the prediction. Correlation coefficient is between -1 and 1. It's a measure that shows how well data points are modeled by a linear equation. If it is -1 or 1, that means it's absolutely perfect. When R, which is your correlation coefficient, is negative, you have a negative correlation. If this is actually between -0.8 to 1, it's a very strong correlation. If it is -0.6 to -0.8, that would be a strong correlation. If R is equal to 0, there is no correlation between the data, meaning you can't find a line. And when R is positive, you have a positive correlation. And once again, that is at 0.8 to 1 is a very strong. And then positive correlation. And 0.6 to 0.8 is a strong correlation. Now, with this, we're going to be doing this on our calculator. So, whoops, bye pen. The way that we're going to be doing this is we are going to be writing a prediction equation. This information here about the second button and 0, I'm going to show that on the calculator, but that should be 0. Type the wrong button. And I'll be showing that on my calculator on how to do this. And then these options here, directions here, are the directions on how to do it. Stat, and then option, clear buttons. Anything that's in caps are buttons that you push, and anything that is not is something that you choose. So we're going to do that here in a second. And then on the back side, when you make your prediction equation, you're going to substitute in a value, or you can go through this process here. I don't do this 6-step process, I just do the first two. And then you're going to interpret your correlation coefficient. When your value is between 1 and 0.8 or -0.8, we're going to say that the model is very strong and accurate. And if the R is not between those values, specifically 0.6 to 0.8 and -0.6 to -0.8, we're going to say that the model is not strong. We're just going to say it is strong and accurate. So what we're going to do is we're going to do some work here. I'm going to zoom out of my picture here. Apparently I am zoomed out. I'm going to zoom out a little bit more. Apologize, there's my backpack. Alright. That way we can see my calculator at the same time. So what I got going on here is we're not going to draw a scatter plot of any of these problems. Okay? And then we're going to talk about this. This is your table. Lists go list 1, list 2, list 3, so forth. We always use list 1 as our X and list 2 as our Y's. And literally we are going to let the calculator do everything for us. So the first thing we're going to do is we're going to hit the second button, and then we're going to choose 0. And when you do that, it pops up with your catalog. So what we're doing is we're setting up our calculator. At this point, if our calculator ever dies, and it's an electric calculator, like, you gotta charge it, you have to do this multiple times. So this A up here at the top means you can hit the x to the -1 value. So x to the -1 is right here. If I hit that, it takes me to my D's. And what I'm looking for is diagnostic on. When your arrow is at diagnostic on, you're going to hit enter. And then you're going to hit enter again to where it says done. What that does is it allows your correlation coefficient to be found and displayed on the calculator, meaning you're running a diagnostic on your data. So to solve this, pardon me, you're going to hit the stat button, okay, and you're going to hit edit. Now I already have data points in here which actually match and everything else, but I'm going to show you some buttons. So delete button is really awesome. Okay. If you delete up here on top, that doesn't work. It deletes out your data points, or your lists. If you want to delete all your data points, you can hit clear on the top of the list and hit enter. But now I only have one list in my calculator, so I'm going to hit the stat button. And then I'm going to go to 5, and I'm going to run setup editor. Once again, stat button, choice 5, enter allows you to reset up your calculator. So with that, we're going to run stat again. We're going to go back to edit, and now you can see all my lists have returned. So I'm going to enter this data in, and as I enter it in, I hit enter every single time. Okay, when I get done, both of these lines should be in the same spot. This one is not, so I'm going to arrow over to the left, and I'm going to hit delete on the information that I do not want. When I check that all these points are lined up, I'm going to hit stat again, and I'm going to go right arrow over to calc, and I'm going to choose option 4, which is lin-reg with slope-intercept formula the way I like it, versus one down here for 8. I'm going to pick 4 every single time. And then, depending on the calculator that you have, if you have an older calculator, you might have to hit enter again for done. If not, on this newer calculator, I'm going to go down to calculate and hit enter, and then see that it gave me my equation. So what I'm going to do now is my R value is my correlation coefficient. We do not do anything with R squared. And then these 2 point values up here of A and B go into this equation exactly as it is. And then what I do is I write that down. So prediction equation, writing it down is going to be y equals -0.4476190.476x, okay, plus 19.190476. Nope, I missed numbers. 199047619. Okay, that's your correlation, or sorry, that's your prediction equation. Correlation coefficient is actually your R value, which you could round to 9 decimal places, but if you're going to round wrong, I don't suggest you round. It is a negative. or write it all out. Okay. Now, if I've done these 2 steps correctly, I'm setting at a level 2. Now, if I interpret the results of this, I look at my negative slope, which plays into my negative correlation coefficient. Since that's negative, I have a very strong negative correlation of data, meaning that this value is between 0.8 and 1, either negative or positive. That allows me to know that my data is very accurate, which has a very strong negative correlation. So these 3 things absolutely together perfectly get you a level 3 on the standard. Plugging a value in gets you to a level 4. So on this graph, 1985 is represented by years since 1985, and then wants me to predict the percentage of students who will send applications to 2 colleges in 2010. So with that, I need to take 2010 minus 1985 and get 25. So what this is going to be is this is going to be my x value in this equation. So what I'm going to do is I'm just going to type it in. So negative 0.4476190476 parenthesis 25 parenthesis plus 19.19047619 and hit enter. When I do that, I get 8. So my answer would be 8% because that's what it's asking me to do. Okay. On this next one here, this changed the order of how we ask our questions. First and foremost, anything with a question mark is a prediction. So that's the value I want to predict. And when I do data in my calculator, I literally take the time to just type in exactly what this is. My equations will be bigger, but it's easier, in my opinion. So, once again, I'm going to go put my data in my calculator. So I'm going to hit stat, and then edit, and then I'm going to take the first data information, which is this first column, and I'm just going to type over my information. And then I can see that I typed this in wrong, so I'm going to hit arrow back up and I'm going to type over it, make sure I put 2000 correctly. And then I'm going to go up to the very top and I'm going to re-enter the numbers. So 9867. And I can see that these 2 points line up exactly. I did not enter in 2015 because that would make my data uneven. So now I'm going to hit stat after I double check my numbers one more time. Okay, so now I'm going to hit stat. I'm going to arrow over to calc and I'm going to choose 4. Just hit enter. And I write down that equation. So the equation that matters is going to be y equals 1349.867133x minus 2650768.344. And then I'm going to go to my R correlation, which is 0.996, and if I round to 4 decimal places, 9, or I would write it all out. Since this correlation coefficient is positive and my slope is positive and this is greater than 0.8, this is a very strong positive correlation, meaning my data is very accurate, like nearly perfect because it's almost 1. And then I'm going to use the equation, that is what I wrote down, double check I wrote down everything correctly, and then plug in the number of 2015 to figure out that answer. So I'm going to go 1349.867.133 parenthesis 2015 minus 2650768.344, enter. So in 2015 the income is going to be roughly 6,000 or 69,093 pretty much. So 69213.93 dollars. Why did I round up? Because it is money, so you should round up. And last but not least, wonderful equation here. So I'm going to hit stat, and then I'm going to hit edit, and I'm going to go type in the second column here first because that's the column I'm already on. So 19, 23, 27, 35, 39, 36, 39, 45, and then I don't have data for this because I haven't predicted it. If it falls within the middle, same thing. And then I'm just going to go up here, type it back in, and then I'm going to go stat, calc, 4, enter, 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 and I get those answers. So once again, this has the positive correlation coefficient as well. It's between 0.9 and 0.1, which is a very strong, nearly perfect. And then I'm going to write my equation down. So first and foremost, correlation coefficients, the very last thing, it's R. So 0.9619. So R equals, not R squared, and this is a very strong positive correlation. And then I'm going to write the equation down that Y equals 2.47275.405 x minus 4904.905744. Type that in. I'm going to predict 2010. Subtract off the 4904.905. I'm assuming that's a 144. 65 seems reasonable. I'm going to go double check that. Nope, that is a 7. So, let's see. Second, insert. There we go. So, predict and predict the number of active clusters. You can do not money, Pomeroy. 65 clusters, 65.3 clusters. Just remember, woodpecker clusters can't be technically half of a cluster, so rounding doesn't really work. Just letting you know on your homework, which I swore I had a copy of it here. Oh, I do have a copy of it. So like on your homework, you're not going to have to worry about doing the scatter plots, but where you have data that has a question mark on it, you do not type that one in because it would make things uneven. So only type the things that can be matched, and then that is what your predict.